Alright, I'm going to try to stay calm in this, I'm gonna try to stay calm in this, and yeah, so I was leaving off basically magnetism, and I wanted to explain, uh, once more, when you're talking about Heisenberg uncertainty, okay, people get the word uncertainty and, unknown mixed up, and I was trying to do that subliminally, like I kept using the word unknown because essentially uncertainty declares that you have come to an understanding that something will always be unknown. So angulars or gravity, like for instance, the measurement of gravity is a known because it has a certain equation, it has a certain amount of newtons to kilograms to mass and all these things. And so I'm just saying conventional physics, they don't go by uncertainty, they go by unknowns because they say that they're certain about the newtons and the mass and the kilograms, the speed of light. And so this is why I'm saying they don't use these principles that are held in Heisenberg, where you're basically just using waves. You're using the equation with gravitational waves. So you're saying there is gravitational constants and there is waves, uh, but you'd have to be uncertain because it's going to have to ellipse or lapse around time. So the lapse around time gives you this uncertainty principle because you're not really the time is it's either detestable or untestable because you know that you can't figure it out just through pure cosmological optics. Okay, like earthbound optics. These earthbound optics aren't going to be able to give you infinity, so they say, well, there's a cosmic background radiation where there's another cooling down that is outside of our perception. So, oh, we'll just add more black holes and their cooling, since it's obvious that that's what black holes do because they're they don't hold any stardust, they don't hold any stars, they don't hold any heat, they don't hold any of the radioactive stuff, photons, iron, all that stuff. Iron has to be able to absorb the heat, and that causes basically the properties to decay, and that decay is melting. And as was said, that's what happened. That's what's happening in wiring with the conductors. So over time, yes, if the wiring isn't constant enough, or if you don't have any like real absorption product, or like some type of insulator like aluminum, like it's not going to melt on the outside because the electricity that is flowing through isn't going to be able to get to the conductor barrier enough to be able to hit the next insulator, which is usually rubber. But if there's a filming of aluminum inside of that inside of that conductor, then the absorption happens slowly. Things like that, or there can be another insulator outside before it gets to another insulator to prevent fires and things like that. Um, 'Cause, yeah, essentially, if there was anything that stopped the current, stopped what is it called? Like, yeah, well, just the current of electricity. Like if there was a hole in the wire, or if you try to saw or slice through a wire that is still in its socket. Um, and I'm just talking like about a free wire. Okay, you plug the free wire into your TV. You'd plug the free wire into your TV, but if you unplugged it from your TV, you'd notice that it's an alternating current because if you try to cut through it, um, then there'd be like a little bang or a pop, and that'd be all of that electricity trying to escape through the hole or to through the incision because it's still flowing through. That's why um, it's not necessarily the alternating current exists in the outlet. So if you actually unplug the entire wire, if you unplug the entire wire and then try to cut through it, you wouldn't have that problem. But if it's still plugged into the outlet, then you have that direct current flowing through the outlet. But that outlet essentially plays the part of this alternating current. So if you turn your light off, okay, it's not gonna be firing magnetism or electricity through the light bulb. So after the light bulb cools down, you can like unplug it, right? But just saying it's still a direct current. The current is still flowing through. It just has something that'll insulate it has something that'll insulate at the end of the direct current before the light bulb touches. For example, it could be just another conductor, and I'd say even something like a conductor with some type of insulating film over like aluminum uh, would be able to propel the direct current from flowing out of uh, the socket. So because you just can't have these things free flying around. You can't just have, it's like the Tesla energy where it's just flowing constantly. Like you just have lightning bolts flowing out of some sort of retainer, like some sort of tower, like some sort of small tower, metal tower, um, that is essentially the conductor. It would just keep flowing out if there was no insulator to be able to cut it off. But I mean, you could have like a really big light bulb on top of the tower if you had some sort of insulator uh, that had some type of conductor, and then that would transfer enough watts. Is what I'm trying to get at would be the perception. So um, that was a little bit off, but I'm just describing this uncertainty thing. Okay, so like an uncertainty thing could be an uncertainty thing could be like, well, we don't know if like energy, actual Einstein energy, is flowing and filling up the actual conductor. Um, when we turn a switch and stop the alternating current or stop the direct current, um, we stop the direct current going to the light bulb, so we turn off the light switch, for example. That means it's an alternating current. Are we saying, well, uh, it's unknown? If we say it's unknown that there is energy, okay, Einstein energy going back into, I just say Einstein energy because kinetic energy to me is essentially dealing with subatomics. And we don't get until we don't and that begins this in the 1700s and we don't get to it until the 1930s. We're essentially getting to it in the 1800s with magnetism, but it's not enough. They don't have enough modeling to be able to say, well, yeah, we have this. They're just using magnetic lines and stuff. But essentially, when you get to the atom, is when you start using kinetic energy. So that's their flaw there. But if you're using this Einstein mechanic, then you're just saying, okay, well, it's unknown if because this is the Faraday paradox. The Faraday paradox is when you cut the direct current off. Okay, there's no more direct current. There's no more flow. You use your alternating current, and you cut off the direct current. Is there energy flowing back in? Like I think the Faraday paradox says there has to be like a 5% or 1% energy flux back into the processor or into the conductor. So that's a problem. I mean, if you just say you're uncertain, well, you don't know, but we definitely know that energy is flowing out. Okay, so that's the Heisenberg principle compared to the Schrodinger. Again, the Heisenberg principle uses waves and time to correlate to rationalize that there has to be a stoppage in I don't know, like perceivability because you can't move any further. You're not going to be able to move past the point when you're dealing with time because you know it's going to like you assume that it's going to be something infinite, so you have to make these assumptions. When you're using Schrodinger, okay, Schrodinger is like one of these pi. It's like one of these pi equations that just goes infinitely, because essentially pi is creating a circle, okay? But it's saying like what radius? It's saying like the radius, I don't know, diameter squared or something or whatever it is. But essentially, you're making angles with your radius. So it's saying it's this constant with circles because you can never really have. I mean, you can have like a 1 degree, but think of any number that is less than 1 degree that you want to make an angle that you want to make your slice with. Any number that is less than 1 degree, you make your slice with that. Um, so zero point zero 0.01, 0.001, it doesn't matter. I mean, you can go all the way to zero, infinity, one. Essentially, that's what pi is. So it's one of these things that uh, it disturbs natural order, I guess, because you're saying, well, you know that well enough. Like you're playing God, you know that you're playing God or goddess, and you know that there is that many angles associated with, like the circumference of a circle. But you're technically talking about angles. I'm just saying. So it deals with waves, Heisenberg uncertainty principle, and I would just say Schrodinger unknown principle. So the Heisenberg uncertainty, okay, it's uncertain. So you make the conscious effort to be able to understand that there is uncertainty in the universe, and you use waves like the gravitational waves, or like basically waves and time, and those are interchangeable. With Schrodinger, everything is unknown. Everything is unknown, and you use waves and frequency, in my opinion. Okay, and frequency is going to deal more with the gravitational accuracy as opposed to gravitational waves. Okay, so waves are sort of metaphoric and pun intended, and frequency is more calculated because you're either using photons or you're using these subatomics, and by subatomics you use um, by subatomics you're reinforcing mass, things like that. Basically integers or integrals, meaning that you have you have principal you have principal calculations already, for what an atomic bit weighs. So like an atomic bit weighs 10 to the billionth of a pound, and like 10 to the billionth of a pound or something like that. And then there's a billionth there's 10 to the billionth atoms like in the mass. And um we're going to do some angular momentum here, and the angular momentum already has a degree, like built-in degrees of gravitation. So that's the difference between the Einstein ring or the Einstein eclipse using Heisenberg, or the Einstein ring or the Einstein eclipse using Schrodinger. Okay, because Schrodinger, they're going to give you some photoshopped bullshit that is in outer space that could never look right, and it's just this telescopic image that is really photoshopped. But they're giving you the idea of what their equations are doing. They're giving you the ideas in that quote unquote uh, Einstein lens. But they just use the Einstein lens because that's what they're using for. They just use the Einstein lens because that's what they're using for. What am I trying to say? Uh, their equations. I don't know. I forgot what I was going to say. But they're not looking at the equation for what it is. They already have these standards. I'm just I'm just saying, if you look at the sky after a if you look at this if you look at a really clear sky or a really humid sky after a rainstorm, like a sky in Florida or California, you'd be able to see a ring around the sun, especially at high noon, like on the beach or something, like on the coast. And you'd see this big ass ring, but you have to understand that there's a gravitational configuration happening there, and they're going to tell you that it's happening in outer space over the sun, which is completely bonkers. Okay, like I mean, there's no way that There's no way that somebody in the 1800s would think to say, oh, that ring around the sun is coming from outer space. So they have to make it. So they have to somehow like make it realistic. Okay, and this is my problem with their literalism. And these are the mathematicians, and so not only do they make, so they try to say that these are models. I guess they try to say that these are models, even though they write papers like um, there's actually something happening. So what I really wanted to talk about, and it's this a priori, it's this a priori or this necessity to call evolution essentially an unknown. Okay, because they don't want to say evolution is uncertain. We're uncertain about how evolution spawned. They want to say, well, it's unknown. Okay, and that's the importance of the HAL 9000, and that's the importance of just roboticism in general. Thinking that they can create emotions, or thinking that they can recreate evolution. Okay, and this is my point. Like if you have, like I was talking about like photons entering a room, and photons enter a room. Okay, um, photons enter a room at a certain speed, at a certain rate. You could say that's kind of obvious because when you open the closed door, they enter and they have to reflect essentially off the wall. Uh, the quantum field theory, essentially what they're playing with when they Photoshop things. The quantum field theory, when they Photoshop Einstein's ring, at least, not like if you see a real one. Um, the quantum field theory is going to say that the light is diffracting. Okay, that particles are diffracting. So they don't go by reflection in that case, or maybe in any case, they go by this diffraction quantum theory. Okay, and so essentially they're saying in a double slit or a single impediment experiment, or even an eclipse like the one in 2016, that light is being bent and it's being diffracted by gravitational forces. Okay, um, I'm saying there's no way in hell it's excuse me, there's no way in hell it's being bent. If you looked at the original picture of the Eddington experiment, the moon I mean, you see it in movies all the time. They show these enormous moons, these enormous setting moons or rising moons, or vice versa with the suns. They show these enormous suns and moons, and it's because of the lenses. It's because they have reflective lensing, not gravitational lensing. There's no such thing other than an idea or a principle or a model of gravitational lensing. Other than that, it doesn't exist. It only exists on paper, pretty much. And yet they still say that they have some three-dimensional cosmic, or they say that they have a three-dimensional cosmic plane, um, compared to a new Einsteinian cosmic plane or whatever. And this is because essentially Einstein was sold out or bought out, and they started using the Schrodinger infinity principles, um, that can just fool everybody. Because if they're using Einstein with the Heisenberg uncertainty principle, then they'd have a clearer picture of what was going on. But um, I would say that there was a lot of renovation. There was NASA and all this stuff. Innovation, I should say. So Schrodinger just makes everything more spectacular. But Einstein equations can be basic if you just look at them algorithmically, or you look at them algebraically, and you don't look at them as like uh, inputs into the universe. I think they just try to hold these things as inputs. So if there's two constants or even two velocities, well, there's two constants in special relativity, and there'd be two constants would be the universe and the Earth, and then there's two velocities in general relativity. That's special relativity. In general relativity, you'd have two velocities essentially, like the sun and the Earth. So that's essentially um, what you're supposed to subscribe to, the differences. But I'm just saying, if they subscribe to time, again, time is going to be infinite, then they just have infinite variance in their universe, and that's through the Schrodinger thing because it's an unknown. Because, well, we don't know where we're going next. Like now, we just have this cosmic background radiation, blah blah blah. Um, yeah, and then again, you can do the same thing with velocities, and essentially they cheat velocities because they use this speed of light thing. So they say that they have some consequential evidence of this universal pattern or whatever it is through these speeds of light because that also contributes to their gravitational constant and that contributes to their atomic constants, uh, their bit forces, and all that stuff. So yeah, I was talking about like the door and everything. So I mean, if you open your, I mean, if you open your door, well, I'll say it like this: like if you look over like a horizon, like a hill, well, it has to be like a street, like a tar, it's like covered in tarmac. Okay, it's like animal bones or whatever the hell. It's like animal bones and carbon. I don't know. I heard tars made out of like grounded up bones, like grounded up animal bones, like so they don't waste all of the slaughterhouse uh, bodies. They grind up their bones, and that's what they put in tarmac. I did hear about that. Like they put, you know, animal products in cigarette butts and stuff. Like that's what I've heard too. But anyway, if you look over the horizon, the horizon of like a street, okay, just remember, event horizon is the black hole, and a horizon is just anywhere that you have to look over. Like anything that you glance over that like has a sun and all that. But the event horizon is described as the black hole because that they say it's the event horizon because well they can't really define the gravity that goes into a black hole. They don't understand how the galaxy can actually. I believe that there's a galaxy. Okay, I just don't believe that the black hole is an event horizon that sucks everything in and spits it back out as radiation. Like it consumes radiation and spits out radiation. Like that doesn't make any sense to me. Yeah, so that doesn't make any sense to me. I think it's just all kind of I think it's just all traversing, like it's just transient matter that is obliged by the gravity and all that stuff. I don't think they can prove this event horizon thing. Well, they probably just say it was never really the event horizon. They just have like their marks just like say, yeah, it was never really like an event horizon. It was never really a big bang. So I'm just saying, if you look over that like hill and it's like a really hot day, then you recognize that or somebody like if you go for a jog or something on a really hot day, well, not really like not exactly a hot day, but like a cool like I don't know California. Well, it's not like you don't even have it. You have like zero humidity in California, so like the air's that means like the air's really thin. But like yeah, if you're like on the East Coast and it's humid, then you'll have like you'll be steaming and everything like if it's cool enough. Okay, so um if the temperature like that's where you kind of have to say temperature if because the temperature of course depends on the angle of the earth facing the sun and everything, so the temperature does matter in that case. um but if there's enough humidity and the temperature's low enough, then you kind of like proliferate steam. um like you can actually see you're sweating, but you're also like cooling down at the same time. It's a little bit, I guess, more diverse with the human body, but if you're talking about like this horizon over the tarmac, I don't even know, like so, and it's like a really humid day, then you'd be able to see basically steam, like you'd be able to see like steam like rising from the street, like on a really hot summer humid day, you'd be able to see steam essentially rising. Okay, and I'm just saying, um, it's a little bit of it's a little bit of an illusion. Okay, and my point would be is that you wouldn't see. Okay, because I mean I've kind of realized that I've never really been able to see the steam if like the sun was in my eyes. Okay, and then earlier I opened my door and I could see the steam again, but it's really cold outside, and so when I'm letting out the hot air in my house or whatever, it's getting out and it's going into the cold. It's going into the really cold air, and you're able to see the steam. So why do you see the steam? Why do you see the steam like on a really hot day, and why do you see the steam on like a really cold day? Well, I'd say because first of all, like like I had to recognize that the angle, okay, like if the sun was in my eyes, I wasn't gonna be able to see the steam coming out in the cold air either. So I realized that the sun must have been facing sort of the bits of matter or the air. So essentially, I was able to see the air, or essentially, um, you could say that you can only see the air. Well, the thing was, I wasn't even looking at the air. Okay, I was looking at the shadow, and I think that's what the thing is too, because I'm not looking at the I'm not like it's a really cold day and I let out the hot air and I see the shadow of the steam coming out. I'm not looking at the air, I'm looking at its shadow. So then I had to say, well, that must be the reflection, and the reflection can't be covering my eyes too much, or I wouldn't be able to sense it or whatever. I wouldn't be able to see it. Um, and it's like you can only see that steam on a really hot day coming like rising from the tarmac when like rising from the tarmac when it's when you have sorry when you have a horizon, because like there's nothing in the background, like there's just like houses on either side. You're going over a hill, and then you just hit, like all you can see is the horizon and the sky, but you see the steam coming up. Or you glance over somewhere, and you have like a perfect sort of shadow. Like you're not again looking at the sun, but I'd say that you have to have because again the tarmac is going to heat the air even more since it's like carbon, um, and it's more, I'd say it's more rubbery. Like tarmac is like the street tarmac is more rubbery, and uh, it'll have like that elasticity. Um, but they also all you have to do is just cook it and let it cool, cook it, let it cool, cook it, let it cool, and then that stretches and stretches and stretches it out. So something like a glue, cook it, let it cool, cook it, let it cool, cook it, let it cool, stretch it out, stretch it out, stretch it out, stretch it out, and then finally let it cool. And sorry, well, and then you like have a hot product, and like that cement mixer, okay, that cement mixer, it'll keep it moving, so that'll essentially keep it from hardening, from like drying, so that like that mixer, that sort of deal, that mixer and everything, that'll um that'll prevent it from cooling. And then when you set it down and it just comes to a complete rest, that's when it'll start hardening again, and or it'll cool and hard, and um and then they go over with like the street, what, like they flatten it out and everything. I'm not going to get into like why it's black or why plastic is clear or white, but yeah, essentially, I mean, it's carbon, so essentially you could just say plastic, they just thin it out a lot more, so it becomes clear. Because if you hold like oil, if you held oil in both of your hands, like you just looked at a like a puddle of oil in your hands, it'd be clear. But we like essentially, if you look inside a barrel of oil, then it's going to be like black. So I mean that'd be like why I'd say plastic is clear and the tarmac is black. Um, so again, just more waste. I mean, not essentially waste, but I mean it really is waste if you're not scientifically methodical about like how you're using it and everything. But yeah, so my point is that you can see the shadow of these bits of matter, or you can see um, like a cloud of these bits of matter in the heat. Okay, so you see a shadow, but it's always a shadow. I'd say it's more or less a shadow because the sun would have to be like behind you in some sort of angle to allow you to see the little cloud of hot air that rises in the summer or the shadow of the hot air that you let out in the cold weather. The sun would essentially have to be behind you, and you just have to know. I mean, this is my point that I'm getting into is that you are essentially getting into nuclear fission and nuclear fusion. And this is, I can't think of like a more important thing to talk about, especially if they are out there they're trying to prove uh what is it called? What is it called? Um Jesus Christ, what is that word called? All right, sorry about that. They're trying to prove emergence, right? That's what they're trying to do. They're trying to prove emergence, okay? Emergence of life, emergence of the universe, it doesn't matter. And they are using the Schrodinger. They're not using uncertainty. They're 100% not using uncertainty. They're sold out if they're using uncertainty. Okay, they're bought out if they're using uncertainty, and they're turning around. Um, they're turning around and saying, okay, let's use the Schrodinger method again. It's all unknown. I don't know. I don't. Again, I don't know is their motto. If they're not uncertain, they will prove that they're certain. Okay, and they're never going to be uncertain. They're always going to be uncertain, so they're always going to try to have this lapse in certainty, and it's just such bullshit. And that's why they're bought and sold. Um, so they're using the Schrodinger. But anyway, I'm talking about okay. I just had the idea that the and this is talking about monopoles. Okay, this is going to go really deep into the monopole thing because you're talking about monopoles in the sense that they have to fuse together to be able to form actual atomic bits. Okay, you can use and well you just use fusion. Okay, the monopoles have to be able to fuse into the dipoles, and the dipoles like an electron and a proton and a hydrogen bond or a 666 carbon bond. All those have to have polarization. And when they have positive negative charges, they're going to be dipoles. When the negative charge and the positive charge are floating around in space, okay, so the negative charge is going to try to pull in a positive charge. That means they're fusing. And realistically, I think that anytime that you have some sort of electricity going, you should say that there are monopoles that are they are they are in the fission process. Okay, so they are in the fizzing process or the fission process. And the fission process, that's why they have nuclear fission and nuclear fusion. Okay, but they don't have any and they're doing all this stuff and they're fusing particles and they're melting or fissioning particles. So they're fusing or fissioning all of these particles, but they never say that these monopoles exist. Okay, they never say, to my knowledge, that these monopoles exist. They only say that those monopoles can exist at 20 20,000 billion times hotter than the sun, which is really corrupt science. That's just extraordinarily corrupt. And it's just extraordinarily corrupt. And you have to just say, I mean, it's just really great news that, yeah, like monopoles really should exist on Earth. They shouldn't just exist at 20,000 billion gajillion times or 20,000 billion Kelvin hotter than the sun. They should be able to exist on Earth. Why don't we just use these properties on Earth? I don't know if anybody has done that before, but I'll have to double check. Yeah, I mean, I might be way late to that one, but I'm just saying, yeah, the monopoles should totally exist anytime, that there was nuclear fission and any time that there was something melting. So essentially, when you have electricity through a current or electricity in current, you could say that it's fusing. But when the magnetism is like, I mean, I'm not saying the magnetism, I'm not saying the energy is entering from the outside into the direct current. I'm just saying that the buildup of particles, since the metal, the copper wiring and all that stuff, it is a conductor. I'm just saying that induction is gonna be shooting all the way through. And when that induction happens, or when that induction, because you should be able to say that induction is happening. I think, like I said with the lightning, when that induction is happening, then the fissioning process is going on. But when it actually happens and the signal gets passed through, who knows how fast that is at the speed of light, let's say, then it's actually fused together. So anytime, but that's when you have an alternating current and you cut off the current. So when you want to use your direct current on like when you want to use your direct current to send it to the light bulb, when you um when you actually turn on the light switch, it's gonna release that insulator, and then that direct current is going to start fissioning, and that fissioning is eventually going to lead to the fusion of electricity into that light bulb because of the magnetism and all that stuff. Okay, like the magnetism causes this fissioning, and then when it's in full fissioning, that's when you'd call it like a nuclear fusion. Okay, but they want to talk about nuclear synthesis. Okay, so they're talking about nuclear synthesis in terms of what actually created like matter to begin with, what actually created bits to begin with. So they understand that. They definitely understand that. That they just don't want to use uh they don't want to use like nuclear fissioning. They don't want to use nuclear uh fusion celestially. They just want to use it sort of unknowingly. I don't know, it's ridiculous. Like they don't want to be certain that they can't prove the Big Bang or something, or that the Big Bang is just supposed to be a model. Like if they know the Big Bang is a model, which they're all picking up on now, or seem to have picked up on, or have already known, like what are they talking about? Like why can't like how does nuclear fusion and how has nuclear fusion and nuclear fission not already peaked? Like I don't get it. So they're really saying that they're going to fuse DNA like a DNA, like they're really going to fuse particle bits together to be able to create a DNA strand or something. It's so ridiculous. It's because now they're out in space saying that, oh yeah, like we can do, we can grow kidneys better in space. That's really sad. So anyway, I'm not like 100% backing this, like for sure, but it just seems like they kind of use the Cartesian, like these right angle rules to really surpass everything. And of course, Cartesian stuff, um, that's all before Newton, and then you basically have somebody who is epistemically, like this guy's an epistemic, and like this is the guy Karl Popper. This is how they want to like prove emergence theory. Okay, like emergence theory is somehow like we know exactly how evolution started on Earth. Okay, it's fucking impossible. Um, all that stuff. I mean, yeah, isotopes are real. Isotopes are real, but in the sense, what what's the difference? What's the difference if they're measuring isotopes? I mean, it just doesn't make any sense. Like they have these nuclear reactors to be able to fuse things, and you're telling me that they can't they can or they cannot fuse everything. If they have the ability to be able to fuse everything, okay, we're done. Like conversation over. If they don't have the ability to fuse everything, meaning it's in a fissioning process, and whatever matter they have, nuclear they take it to the nuclear fusion reactor and they completely fuse it. You're telling me that there's something that they can't do with that, and they're trying to figure out, well, they just need a hotter fusion mechanism. So they're saying that they can somehow elevate the temperature. They can make the temperature on the nuclear fusion machine rise to be able to. I mean, what else could this possibly have to do? Like, this can't have anything else to do. I mean, if they're going to play God this much, if they're going to play God this much, then yes, they have to be able to prove evolution or create a quantum computer, a feeling machine, which they're not going to be able to do. Machine, like a an emotional receptory, but they cannot. They can't do this. So, like, are they just doing lab experiments? I mean, okay, I mean, if I'm doing politics, I really don't give a shit. But to me, they're doing absolutely nothing, and it's a waste of fucking time. And I'm just trying to point out how it's a waste of fucking time, especially because they have Karl Popper, and Karl Popper, like to prove this emergence theory, Karl Popper was he was against he was essentially against Darwinism. And Stephen Weinberg even seemed to be, and Stephen Weinberg was a proclaimed atheist who was friends with Dawkins, who died recently, but he even seemed to be a little bit intimidated by, did I say? Yeah, he even seemed to be a little bit intimidated by Darwinism. Okay, so this guy Karl Popper, um, and one of yeah, and this guy Karl Popper, okay, is an he's one of those epistemists or whatever, like those epistemology epistemist people, like those epistemic. They're anti. I mean, what is that word? The like they're an epistemist is like someone who's Curian, like a Procurian. A Procurian is someone like more of a pessimist attitude about life. An epistemist was more of like a Kantian, like someone who's a Kant, someone who was into Kant, and like around the 1700s. But Karl Popper was definitely an epistemist. He was definitely a supporter of Zionism, as was Weinberg, and Weinberg was a atheist. Okay, and Weinberg was this big. He had this big, and we're also talking about steady state Big Bang. Okay, so it's not called firecracker theory. It's called the steady state. It's called the steady state Big Bang. Okay, and steady state Big Bang is supposed to be this model where, like that I was talking about in the last video, where the temperature, rises and falls and rises and falls, but it starts off at a really high temperatures, billions of times higher than our sun, and that's when everything was monopolar. But they can't prove that. I mean, they obviously can't prove that. It's just a model of where something should have nuclear fusion, but we're not creating anything on Earth that is hotter than the sun. So it doesn't make any sense. So yeah, you have that nuclear fusion. You can have that nuclear fusion happening on Earth. I'd say with electricity, or you'd be able to see air molecules through the shadow of a sun. And you're going to tell me that that's not fissioning. That's not nuclear fissioning, because you're essentially talking about or it might be like anatomical fissioning or anatomical fusion. So that's really sad. But like um anatomics, I don't know, nuclear. Yeah, well, I mean the nuclear anyway. So that might be how they get you, because they'll call nuclear energy just high energy, and that's how they get you. Well, there's a lot of math involved with all that monopoly and all that stuff. So it's just it'd just be their excuse to say, well, we're trying to figure out emergence, how life emerged, how anything emerged on Earth. I mean, it's not just life; it has to be the excuse that we have to figure out everything on life. And I don't know, I don't exactly know why you'd have to figure it out if you can just say plainly, well, yeah, we have fissioning and we have fusing going on. It just doesn't make any sense to say otherwise, unless yeah, you have this epistemic ideology that we have to leave it open to debate. That there has to be not uncertainty about we're going to figure out emergence, but it's unknown whether or not we're going to figure out emergence. Therefore, I mean that's a total ontological epistemic view, and this is Karl Popper, and Karl Popper's sort of anti-Darwinism. So I mean that's just more religion in the atheist community. Okay, and yeah, I mean, I can't really get into cryogenesis. I really just am not interested in cryogenesis. I just, I mean, I really just don't care about cryogenics and all that stuff. And um, it's going to cost so much money. And I mean, we have stem cells and we have steroids and things like that. But yeah, So yeah, I mean, I'm pretty much. I mean, it's just a waste to do these things. I mean, it's a waste that we have like this economic system, right? Like this banking system. But this banking system is basically going to take us uh to our fall. Like you could say the fall of the third empire. The third empire is going to fall once this banking system basically falls. And the banking system, I don't see how it's not going to fall because it's a digital software banking system, and it's a digital accounting system. And again, like eventually, the internet is going to have to fail, and the digital accounting system will have to fail. So, I mean, I'm just saying, like like if we ever put any effort into preparing for the end of the internet, like the end of the satellite age, if we ever do that, okay. But like, I mean, if we just don't like ever worry about like, I mean, in my lifetime, I mean, if I have like 40 more years of just not worrying about like anything other than propaganda, I'm gonna be pretty pissed off. But so yeah, I mean, I couldn't really get in. I mean, that was my like wait. That's my one waste argument. And then yeah, but I mean, obviously the steady state. Okay, steady state, Big Bang, not firecracker, Big Bang, but steady state. We're just talking about uh, really high temperatures creating monopoles and then cooling down and fusing. Okay, so nuclear fission is really high temperatures. They just exaggerate the temperature, in my opinion. And then the fusing is the cooling process, and then it'll heat up and it'll fission again, and then it'll cool down and it'll fusion again. And that could just be nuclear anatomic um, theory. But when essentially when you have, again, like you're talking about like monopoles, okay, like negative floating around trying to find a positive charge, and then when they actually fuse together, then they're fusing in their atom, okay, and they have a bond, and so when it's fusion, they form that orbital like the atom, and when it's fissioning, that's when the electrons and protons are free. And then yeah, so I mean waste cosmos, and yeah, and then it basically just took me to the Fermi paradox. And yeah, I'm a little bit um yeah, I'm just a little bit petrified of the Fermi paradox, just because it's the alien theory. Why haven't we seen any aliens? I wanted to discuss why I wanted to discuss the equation. Schrodinger deals with waves frequency. You can always change the frequency, but you can never change the waves without changing the frequency. So the wave is interchangeable, but the wave will always have a direct change on the frequency. Heisenberg, you just have a wave and you have time. And oh yeah, like I was trying to um, oh yeah, like oh no, the Fermi paradox. You have all these inputs on like I mean, anytime you use a wave, you're talking about the whole universe. So yeah, you just have all these inputs like inputs. The Fermi paradox actually literally I think uses planetary concepts. Well, do we have any like livable planets? So let's say we've discovered like three livable planets. I mean, they're like maybes. Okay, we that might be a livable planet. I mean, by livable planet, like we're talking like no oxygen. We're not talking anything. We're just talking bare minimum. Like we'd be able to land the rocket, and and then yeah, like you multiply that by like another number, and somehow you get like a 10% chance of uh, 10% chance of of other human life in outer space because we're talking about evolved life at least evolved human life. And then also the general perception of that is that just generalizing, like they say, well, humans are what the fuck do they say? Oh yeah, like why haven't we seen like the general consensus on the Fermi paradox is why haven't we seen aliens? Because uh, it's either unevolved, which is so fucking cringy. It's either unevolved or we're unevolved or something like that. So, and then I was trying to talk about it's really bad. It's fucking those fucking government UFOs. Never get sick of them. Um, yeah, people need to be on pills, man. Oh shit. Well, I don't know what else. There's one other. Oh yeah, the many worlds. I was trying to reassert my stance on a many worlds equation. I just can't really remember it. I think it dealt with the I, and sometimes when they use I in equations, it actually means individual. I think it had something to do with that. But yeah, I mean, I did like I did like the many worlds just because it's different than the Schrodinger, but it's also different than Heisenberg, and it gives you like a little bit of a gives you a little bit of a taste of like, well, there's a duality existing because I don't have to be the only, like I'm not the only observer. Yeah, yeah. I mean the Fermi paradox, the alien equation is just bullshit. Like insert how many planets are livable. Insert how many spaceships you might see. I don't know. It's really bad though. And then but yeah, what I like about many worlds is that it just deals with alpha beta, and alpha beta just deals with dualism, and especially because there's like because you add constants, but then it's grounded. It's grounded because it has the gravity. So G is like a certain equation again with newtons and kilograms and mass and all this stuff and speed of light. So it's grounded with that. But yeah. Um, what was I saying? Oh yeah. And then it has like it also has pi intersective, and it also has like 8 divided by constant 4 is what I saw. Like so constant, so there can be 4 constant states. I mean, this would just be one equation, but there'd be 8 gravitational poles in a full circle, and you have 4 constant states, and that would equal like your gravitational pull alpha beta. And alpha beta just means that it's like basically the constant wave or the like just the constant wave, and then there's duality in that. So I was just saying, okay, that's like exactly like the Heisenberg uncertainty principle, except there's Einstein methodology. Just saying like there's more constant and there's an observational, and many worlds came out right around Heisenberg, right around Schrodinger. I think it was like Heisenberg, Schrodinger, or sorry, Heisenberg, many worlds. I think they're very closely related, and I think they came out like around the same 1932, 1933, and then Schrodinger came out like 1935 or something. And Schrodinger is the bad apple. Faraday paradox is the bad apple. Fermi paradox is the bad apple. Karl Popper is the bad apple. Cartesian law, like that's where I was talking about. Karl Popper is the epistemist who is against Darwin. Fermi paradox is with the aliens. Faraday paradox is saying that there's that energy after like after an electrical induction, after an electrical transmission, then energy re-enters the magnetic field. That like there's a constant flux of energy. That's the bad apple. And then Karl Popper was the epistemist against Darwin. I said that. Um, Steady state Big Bang misused. That's just the model of the Big Bang. And monopoles not used enough. Nuclear fusion, nuclear fission misused, in my opinion. Those temperatures can't exist on Earth. Why are we bothering about those temperatures? Like, hurry up and like if you can prove emergence on life, you should be able to prove emergence on life. You're just playing with the Schrodinger. You're not uncertain about that you think you can play God, you think you can play real God, real you think you can play real angels and demons and be able to and create a DNA strand? Yeah, I doubt it. Or be able to create your heuristic algorithmic computer 9000? Yeah, I doubt it. So I just don't see any real point in this. You know, these contingencies on philosophy. What was the other one? Oh yeah, Cartesian law is the Cartesian laws. These are these angles, like everything polarizes at an angle. So they obviously didn't have they couldn't realize monopoles, but monopoles are I'd say extremely important in fusion, at least for the time being. They won't be after we can't use nuclear reactors. Then yeah, we won't have any point to use nuclear fusion and nuclear fission. Like we're all gonna be like fucking embarrassed of ourselves. um yeah, we will just, you know, the future generations will just be shitting in holes, wondering why we were so fucking irrefutably wasteful. But yeah, the Cartesian law, that just does the right angles with that does the right angles with positive and negative and all that stuff, like little Nazi symbols. You know, there's like little Nazi symbols all over the fucking universe or something. Like geometric unity Nazi symbols. Like, yeah, right. Give me a fucking break. Um. So yeah, I'm gonna step back from that.